Mr. Minnick here, helping my Java students understand how a client program, which we have here circled at the top of this web page, how it relates to a class, such as this square class that's the bottom two-thirds of this, how they link up, how they interact with each other. And what we're going to do is we're going to trace the code in the main method. And line by line, as we trace this code, we're going to see how methods down here are called and find out what prints out. As we do that, it's important that my Java students at this early point in the school year that they learn the vocabulary that is associated with some of these concepts. Some of that's embedded into AP multiple choice questions, and it's just knowledge that you should have if you're going to be serious in the world of computer science or information technology and not just a person who plays Angry Birds as a user. You're going to be a developer or an engineer. Okay, let's go. So this short bit right here that's circled, that would typically be in its own file with the name squaretest.java. In Java, the name of a file must be the same as the name of the class that's typed out in that file. And the name of the class here is squaretest. So it would be squaretest.java as a file name. This down here would normally be typed up as a separate file, and the name of the file would be square.java. And it is case sensitive, so the S would have to be capitalized. Well, just for convenience, I put both chunks of code on the same web page. And this could be typed out in the same file, but I had to take away the word public here so that this is just class square instead of public class square. And it would actually execute in Eclipse, but normally a professional would not do things this way. Okay, so let's take advantage of the convenience of having it here in one file. Well, we start by identifying the fact that this circled chunk of code here is called the client class. And it's also known as a client program. Some people would call this a test class because its purpose is just to test the methods like getWidth, computeArea, which are found down here in the square class. So this code is testing this code to see if it works. Before we sell any software that uses square objects, we need to test the methods here. So I could call this just the square test class, which is what I did name it. Okay, anyway, I'm going to call it the client program. So up here in the client program, where we have a main method, and there is no main method down below in the square class. Typically, we don't put main methods in it, regular classes. So in this main method, we execute the first line of code. Well, that line of code is actually two different actions, if you will. The left half of this line of code is declaring an object variable named block. I could have named block anything I want to. It could be named X, but that would be a poor variable name, bad style. So I name it block. And instead of it being a primitive data type, like an int or a double, its data type is called square. Well, that's not built into Java. So if it's not imported up here, which it's not with an import statement, then the data type square must be accounted for either as a linked reference file in the project, like we did recently with the turtle classes, or it must be found as a class somewhere in the current workspace folder where this client program is. Well, we one-upped that. We actually put the square class for convenience right here. So block is a square. That's what we're declaring it as. But now we're taking that a step further. We're setting it equal to something. You would not set it equal to 0 like you would a normal primitive int variable, like score or num apples. No, we're setting it equal to whatever this is. Well, this is a memory address, and I don't want to get into that, but it's a memory address reference from somewhere in the memory. But what you can really think of it as is we are calling a method. And more specifically, we're calling something called a constructor. The word new just has to be there for reasons I don't want to get into. But this right here, square empty parentheses, is telling us to come down here in the square class and find what's called the default constructor. The default constructor is essentially what looks like a method. It's got its own set of curly braces and a method header. And it's the word square with empty parentheses. So we identify that connection. We are not passing any parameters because the parentheses here are empty. Neither are we receiving any parameters because the parentheses here are empty. But where in the world did this come from? My width. My width is illegal, you might think. It's not a legally declared parameter name or local variable. Oh, but it is. Down here, privately encapsulated deep down in the body of this class where it's closing curly braces right there, that's where we find out what my width is. You see, my width is an instance field in the square class. We also sometimes call it an instance variable. I sometimes call it a property, which is probably not the official best name for it, but I'm going to accidentally call it a property for the rest of this semester, so live with it. Anyway, on the AP exam and multiple choice questions, they often will call it an instance field. And my width is more specifically a double data type. And it's private. Yes, you could put the word public there, but you shouldn't. For style, you never tell other people, other classes, or certainly not client programmers. You don't tell them what your social security number is. You don't even tell them your age. It's none of their beeswax. So it's good style in object-oriented programming, according to AP exam people, that properties should always be private. Now they do have to have an associated data type, either int or double. And it could be a string with a capital S. You could even have this be like a turtle object. It would make no sense in a square class. Okay, now why do we name it my? Well, that's good style for beginners in this school year here in Java taught by Mr. Minnick. I always name my properties my something. You will not see that on the AP exam typically, and only some textbooks do this for beginners, but I like to stress it. My whatever. My age, my X position, my Y position, my weight, my height, and stuff like that. If I were a Visual Basic button object, I'd call my back color my back color. Okay, so now we come back up here and we realize that my width is legal. It was already in scope and it was declared as a double, and now we're setting it equal to 0. Now we hit this closing curly brace and we are finished with this default constructor call statement. And by the way, the act of calling the default constructor is called instantiating an object, because now we have a memory address. Some hexadecimal memory address, you could consider this to be like B52 or A3 or R2D2. No, not R2D2, because R is not a legal hex digit in the hexadecimal world of memory addressing on personal computers. So B52 could be a memory address that right now is stored in block. So really, block is a variable name that you could now keep track of, but don't think of it as being 0, because it's not 0. It's really the memory address B52, which is where in the memory of the computer the fact that my width and other properties are currently equal to whatever they're equal to. So in some chunk of memory with a memory address such as B52, my width is known to be equal to 0. There could be also a my height and a my weight equal to different numbers. So don't just put a 0 under block. It's really just a memory address of where there's more information stored. We call that the state of an object. The state of an object is its properties and their matching values that are currently stored there. That's called the state of an object. And really, block is an object variable. This rectangle, you could more correctly consider that the object. Block is the object variable that stores what's called a reference. This B52 is an object reference. It's just a mapping. It's just like if you live at 123 Reading Boulevard, your reference, if somebody said, hey, where do you live, Charles? You would say 123 Reading Boulevard. That's your reference. That's not you, your body, your physical body. Your physical body is like the object, but your reference is just where your family currently happens to live. This B52 could eventually change to like the memory address, say A3. Now it hasn't yet in this program, but it could change. Does that change your width? No. Does that change your weight? No. You're still the same person, you just live in a different reference, a different house. Okay, anyway, back to the tracing code here. We now have traced that line of code. Now let's fast forward and see what the next line of code in the client program does. Oh, we have an object variable named box. It's being declared as a square. So let's make a little a column for it. And what's happening here? Oh, it's being instantiated. It's being brought to life as an object. This time, though, 3 is passed as a parameter somewhere. Now, I'm going to scroll down, and unfortunately, because of my software here, it might now lose all my, yeah, sorry about this. And for some reason, I can't now scroll. So, sorry about the technical difficulties. I lost my variable tracing, but we can redo it if necessary. Now, that 3 gets passed as a parameter and plugs into the formal parameter name width. Because here we have a constructor called square that does take something in the parentheses named width. This was the default constructor that had empty parentheses. The Java just knows which of these constructors to call because when it's empty, it knows to call the default constructor. And when there's a parameter in there like a 3, which is a double, 3.0 consider it, it plugs into width right here, and it knows to call this one. So the 3 plugs in for width, and because assignment statements work from right to left, that 3 in width, Tristan, plugs into my width. And we already know that my width is a legal property name, so everything's good in the world. Unfortunately, you can't just put my width here. And you certainly cannot put my width up here somewhere. Do you want to know why you can't put my width up here? Because normally this would be a different file. And even if it is in the same file like it is here, this set of curly braces clearly defines the scope of where variables are legal up here in square test. And more specifically, these curly braces define local variables that are legal in here. And my width is not declared anywhere up here. My width is down here in this set of matching curly braces. And more importantly than that even, it's private. So anything that's private cannot be used or referred to in another body of or section of code with its own set of curly braces. And this is good stuff. This is important. Don't let other programmers use your properties. It's just bad style. But because of the way the constructor works, the 3 goes in here and temporarily plugs into width, and where it's legal to do this, width then plugs into my width. So because of this width as like a sort of a connector, this is all legal. and it does execute correctly. Bottom line is, we now have two object variables up here in our client program. Block has a width of 0, and box has a my width of 3. So I could say, how many my widths are there right now? And you'd have to say there are 2 my widths. Each object variable has its own my width. Just like in this classroom right now, how many social security numbers are there? Well, I'm counting about 10 students plus me. So there are 11 social security numbers, but they're each private and stored in each variable. Each object variable has each object has its own my social security number. Now let's trace the next line of code. Block.setWidth, parentheses 4. Now that it's been declared and instantiated, you can do things with block. Block.jump, block.shoot, block.crawl, Block can't do fun things like your Xbox game object variables. Block only has these public methods. A block can do a .getWidth, a .setWidth, compute area, and compute perimeter. Those are the methods that make up the public interface. See, public, 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 public. The public interface of the Square class. If I were to build an API and put it on the internet, I would explain what the purpose of those 4 methods there would do. And I'd also throw in the public constructors. Some classes do not have a other constructor that takes parameters. Some classes don't even have a default constructor. Now that would cause problems, because how would you then construct an object to make use of it if it doesn't have any constructors? More about that later in the chapter. Anyway, that's the public interface of the Square class, all the public things that you can now do in this client program. So what do you think a .setWidth does? Duh. It changes the width of whatever variable it's being acted upon. So right now, block is this object. It's the object that's being set width, if that's a word, to set width to something. I was set width. And block is this object that's happening to. So where's this 4 go? The 4 flies down here and is passed as a parameter and plugs into the waiting parameter, formal parameter name that's right here in the setWidth method. And I reuse the word width, which is perfectly fine, because this width up here is only allowed to be used here. This width, coincidentally, is the same name and it's used here. Now that 4 that's plugged in there is now going into my width, and it's overwriting the 0 that was there. Block, for a short time, did have a 0 as its width. But now that my width was overwritten with a 4. We just called what's called an instance method. Methods that are used after the dot, they're called instance methods. Because another vocab word for an object variable here is called an instance method, and I see I did not put that on this guide, which I should have. Block is called an object variable, but it's also called an instance variable, or just an instance. Box is another instance of the Square class. So one Square class can be used to instantiate and declare many instances. And the methods that you call on an instance are called instance methods. Later in this unit, we will learn what a static method is, and that's a little different from an instance method. Okay, next line of code. System out print. Box.getWidth. Hey, let's go see what getWidth does. Oh, by the way, all these methods and constructors, they can be typed out in any order. But it's proper style to put your constructors at the top, and then I like to put my accessors, and then my modifiers, and then my leftover methods that I just call interesting methods. I always put my properties at the bottom. My property declaration statements, like my width here, They don't have to be down there. Some people put the property declarations at the top. They should be put in one spot or the other, not in the middle. That would make no sense style-wise. Okay, what does set width do? Oh, I'm sorry, get width. Get width takes no parameters, and it returns what my width is at that moment of time. So even though my width isn't mentioned here as a local variable, it knows that my width is currently storing, I think it's a 3. And it gets returned as a double. The return type has to be typed here. I'll notice that constructors do not have a return type. They have the word public, but not the word void like you would think. All other methods have to have the word void, int, double, or string typically here in this spot of the method. Okay, so a 3 pops in the parentheses of println, and therefore a 3 prints out. Hey, what if, Charles, what if I had the word box here? Block. What if I did block.getWidth? What number would have printed out for block at this point in the program, Charles? Ricky? A 4, very good. Because block had his width currently changed to a 4, and that's what would have printed out for block. Keep your eye on the this object. If we were playing softball here, I'd say keep your eye on the ball. Keep your eye on what object is being dotted or called. Okay? Better pay attention here. I'm going to call on somebody next. Block.computeArea. What is the width of block at this point in the line of code in this program? What is the width of block? I lost track of what's what because my stuff got erased. What is block's my width at this point in the program? Stephen, what is block's width? 4, very good. Right here, we had changed it to 4. You can barely see that that's a 4. Now, what's the area of a square that has a radius or a width of 4? Yeah, 16. Well, do you want to confirm that? Let's go down and see what compute area does. Oh, it takes my width and multiplies it with itself. Because the square, has the same width and length. So width times width is the same thing as width times length for a square. So a 16 gets returned, comes back up here, and it plugs in to where you called block.computeArea, and as I made obvious, a 16 prints out. Charles, let's analyze this line of code now. What is box's current my width at this point in the program?
3.
Good memory, 3. If you were doing this as a worksheet where you could write on your paper, you would have kept track of it over here on the paper. Okay, 3. Now what's the perimeter of a square that has a width of 3, Charles?
12.
12. You know that from just life. 5th grade, 3rd grade, somewhere. Well, let's go confirm that it's 12. When you call compute perimeter, do not, Mark, do not pass a parameter like my width. You don't need to. Because when you get down here in the square class, compute perimeter knows what the width of the object is. So 3 times 4 is 12. And that 12 does get returned. Students sometimes, tell somebody what their social security number is. No, don't ever tell. If somebody says, what's your social security number? Say, you should know what my social security number is. If the doctor says, okay, you're healthy, your yearly physical checks out. Oh, by the way, I need to know what your social security number is here for my paperwork. Don't tell your doctor what your social security number is. Politely, respectfully tell your doctor that he or she could look it up in your medical file because it's somewhere encapsulated and private to your object information. Your file folder has it in there. We don't like to pass information around as parameters any more than necessary. That's how passwords get stolen by hackers. We encapsulate it as objects. These rules of thumb are good to live life by, not just to program in Java by. Okay, we have now executed the last line of code, and we are done with this sample. I think I tried to make use of everything here. Let's just go over remaining vocabulary that I might not have mentioned. This parameter name width could be anything it wanted to be. It's just a temporary placeholder. Width, W, I like whole words, but anything could have been used there. That's called the formal parameter. What number or variable name is actually passed down there, that's called the actual parameter. That's an important vocab distinction there to make. And one last thing, the body of a method is, well, the code that's inside its curly braces. We also sometimes call that the implementation of a method. That's stuff that we like to keep hidden in a class like Square. How you figure out something's area is up to you, the programmer of the Square class. People who write client programs, they don't care how you computed the area. They just want a method that's named logically that works. They don't want to look at the details of how the code works in the body of these methods. Typically, one person's job is to write client software, like a main method, and another person, sometimes at a whole nother company, it's her job to create a class called Square. So whoever wrote the latest Xbox game that you played, one person creates like the method soldier, the class soldier. Another person writes the actual game, Call of Duty or something, where soldier objects are used. In fact, the same soldier object might be used in different client Xbox games that you buy. They just put a different look to it. But the functionality, the behavior, shoot weapon, is the same darn stuff. Don't get me on a roll. You guys spend $60, $60, $60 on these different games. It's all the same stuff. And better yet, just write your own game. That's the end of my demo.